Hi, Ross. How are you today?
Great. Thank you for having me, Junko. Looking forward to it.
So let me just introduce you to the audience. Ross is the Vice President and General Manager of the Automotive Sensing Division at ON Semiconductor, which is really the worldwide leader in automotive sensing. So previously, Ross, I was actually surprised to see this. Previously, before you joined ON Semi, you were the head of automotive hardware at NVIDIA uh, as a VP of engineering. Is that right?
That's right. That's right. That's where I really started my passion in automotive and just making the cars more intelligent and more fun to be around. Yeah.
That must
Started
have been a really exciting time because it was really at the cusp, and NVIDIA wasn't really so fluent with the automotive industry yet, but it sort of, you kind of guided the company into the new sector, I guess.
Yeah, I think it was the vision of that team started really in infotainment and using the power of 3D graphics and having the navigation and the audio processing and all the really making it a wonderful experience there in infotainment. And then I think just from brainstorming of how we can harness this power to make the car a more pleasant and more safe experience naturally led us into driver assistance and autonomous driving. But it's had really its roots in infotainment.
That's great. So when did you actually join ON Semi then? Which year?
So about late 2015, so just about 5 years. This December will be 5 years. It's been quite fun.
Yeah. But it's a very different company, is it not? I mean, in terms of I guess the breadth of technologies that onsemi brings to the automotive is actually really much broader than NVIDIA. Is that right?
Absolutely. ON has a long heritage and tradition in automotive going back to the 60s, actually. Prior to ON, when it was Motorola and Fairchild, they've been in this industry for quite a long time. And it's actually been a privilege because it gives me a point of view of basically seeing almost all the car manufacturers, all the tier ones that service those car OEMs, and get to engage with them on their strategies, their architectures for the car, and what their goals and vision is for the intelligent car of the future. So it's a really nice point of view, and I'm privileged to be part of it.
That's great. Yeah, no, that it is the well, not only privilege, but it's a real advantage. You actually have a better view of what the customer is actually looking for, right? And but I just want to start out this conversation. Before this interview, I said to myself, I got to do some homework here. So I went to onsemi's website, and I actually watched the promotional video you guys created for the automotive segment. That was very well done. And one of the pitches that I heard in the video was your company is positioning itself to offer tools to change the relationship between a car and driver. And that really spoke to me. The changing the relationship between a car and driver is really central to the era of ADAS, but also down in the line, the autonomous vehicle. Yeah. So here's really my first question. How do you think this relationship between a car and a driver, how do you perceive that this relationship is changing? Can you give me your take on this?
Sure, yeah. You kept mentioning Car and Driver. It reminds me of the magazine Car and Driver, and that was the Car and Driver magazine was all about the car enthusiasts, and the car enthusiasts were all about the engines, maybe the audio system, and it was a small group of enthusiasts. What adding all this intelligence into the vehicles, whether it's infotainment, whether it's digital instrument clusters, whether it's ADAS or autonomous driving, has really expanded the enthusiasts out there. So there's a better relationship between the driver, even the passengers, with the car. In the past, it was kind of a utility. It was an appliance, kind of like a toaster. You get it and you use it. It takes you for, except for the enthusiasts that enjoyed souping it up and making it a better experience. Now, it's kind of democratized the enthusiast market of the vehicle. A lot more people now have a relationship with, whether it's over-the-air updates, even Android Auto or the Apple solution. It allows you to get updates, and the car changes the experience with time. So you get a more fun experience with time. It's not a static purchase. You purchase it, and this is what you get for the lifetime of the car. It's updating, it's improving. So that's one aspect. The other aspect was really also on the relationship. In the past, the relationship was kind of uncompromising. This is how it works. And if there's a failure in 10 years, then people are not happy with the experience. Yeah. Now, with this relationship and the more intelligent vehicle, it's almost that the driver has more respect to the intelligence of the vehicle, that they're a little bit more accommodating and empathetic for some errors. So, for example, you see, if you just go to the web and type Tesla reboot, you'll see all the reboot instructions that people are okay if at times the infotainment system locks up how to reboot it. This was unheard of in the past. Right. So this is kind of a testament to how the driver has become has a stronger relationship and more involved and empathetic to the technology, and as it progresses with time.
Yeah, but I have two comments to what you just said. One is that I think it's not just the relationship. Well, in Tesla case, number one, Tesla has huge fan base. This is really unheard of, right? I mean, I don't think every car manufacturer can afford that kind of a strong relationship between the car, brand and the driver. So I think I would put Tesla, it's sort of like an exception.
It's a unique case, yeah.
Yeah, but then another thing is, I think now we are in the era of smartphone, and a lot of consumers are getting used to the fact that sometimes things don't work. We got to turn it off and reboot. And unfortunately, that sort of, a bit of an inconvenience or not so reliable, software updates, I think conditioning consumers to, oh, well, we got to put up with this thing, right? And I don't think that's necessarily a good thing. So I don't want you to think that's that's a representation of the strong relationship. Rather, I think consumers are putting up with it.
Yeah, no, absolutely, absolutely. Especially when it comes to safety critical applications like driver assistance and autonomous driving. We cannot compromise on the safety of these vehicles. Whether it's hardware or software or integration in the vehicle. The litmus test I use is, will I put my 10-year-old son in a driverless car and have him sent to school? Yeah. And that's really makes people think about, have I looked at all possible failure modes? Have we addressed them all?
Absolutely, I totally agree. Yeah, so absolutely.
Safety critical, absolutely uncompromising, and that should stay the case and the vision for the future.
Yeah. All right. So, knowing that you are the guy in charge at onsemi, developing all the sensing technology, sensing meaning that making the car see, making the car hear, and which I thought that was very important, making the car hear and making the car sense the road. That's what you kind of described what your business is. But, how do you rate the technology solutions currently available on the market? Do you think that we're up to, what what the tier ones and the car makers want, or are they still I'm sure there's still room to improve. But if you look at all the different sensing technologies, where do you think that the industry is still struggling to find better answers or better solutions?
Mhm. Yeah, I mean, um, On Semiconductor and other companies have breadth of sensor modalities, sensor technologies, whether it's image sensing, radar, lidar, and others, and also depth of sensors. So you could have a very small, very cost-effective sensor to a very large, very detailed sensor that can go to Mars and gather data and send it back to us. So you have that whole spectrum,
Yeah.
and selecting which one is important. Now, your question is, today's technology in vehicles, how do you rate them?
Yeah.
I would say they do have their shortcomings. They're not perfect. And it's really because of the constraints that are placed in the vehicle. There are cost constraints, there are size constraints. So there's always a balance of what is the best technology that I can put in, but still maintain the size and the cost of the vehicle, especially in human vision. So if it's a rear view camera, this is really just providing information to the driver or surround view. Those have a lot more constraint on size and cost. So again, they have shortcomings, and oftentimes as you get to higher level automation, level 2 and beyond, sensor fusion helps. So where one sensor is falling behind, the other sensor helps out. The analogy I give to my team is we should think of it, in the animal kingdom like a rhinoceros. Rhinoceros is very powerful, very intelligent, but 15 feet away cannot distinguish a tree versus a human. It cannot classify those two objects. Those are something there, but cannot tell. But its sense of hearing, its sense of smell can allow it, that's so much higher than average, it can help it compensate for the bad eyesight. So same thing happens in vehicles. You have image sensors that will have challenges in poor visibility, whether it's fog, whether it's nighttime. Radar in that case can help. So they all are not perfect. They have some shortcomings, but sensor fusion helps compensate for each other. Some examples of sensors that I'm really bullish on and excited about are lidar. The constraint there is it's quite expensive, so the consumer would just not accept it for light vehicle sales, in that's readily available. Those are a little difficult to make that hurdle in terms of the cost of a complete LiDAR system. Now, as you talk about higher level automation and shared vehicles or commercial vehicles, that's where the economics make sense. Absolutely, I think LiDAR is helping quite a bit on that front.
Are you guys in the LiDAR business?
Absolutely, absolutely. We're in some of the most upcoming vehicles with LiDAR that's adding LiDAR. We're involved with those. Of course, I can't speak about those, but absolutely,
What LiDAR technologies are you using?
So this was through an acquisition of a very bright company in Ireland called Sensel. Stands for Sense Light.
Yeah.
And that's basically, there's two types of technologies. We have SiPMs, silicon photomultipliers,
right,
and the other one is SPAD arrays. So SPAD arrays start to look more like a camera. It's basically an array and allows you to basically take images with depth, while SiPM gives you a lot more range. It's oftentimes used in terms of scanning type of LiDARs.
Yeah. No, that's great, because LiDAR is one area I'm sure that this AutoSense conference as well. There are a lot of LiDAR companies coming in to show off their technologies, and yet that this is one area where there is really no agreement which technology is going to win the market. And I suspect that there's different segments of the market that each different technology will be used, right? Yeah,
that's right. That's right. I think it's going to vary, just like in image sensors, where global shutter sensors make more sense in cabin, monitoring the driver and the other aspects of the vehicle, passengers and others, while rolling shutter makes sense more outside. We think there will be a distribution where near field LiDAR, something more closer to the car. SPAD arrays will be a definite
I see.
winner, while
Right.
SITM for long range would be still a very good solution.
So do you expect, of course, you can't name names, but Elon Musk famously said, LiDAR is fool's errand, right? I mean, this is the quote that it's being so quoted by every publication, automotive publications. And I just want to hear your take on what role LiDAR is going to play.
With the current cost structure, there's some truth to what Elon's saying. It's going to be very difficult, but there are a lot of innovative LiDAR systems now being put together that really brings the cost down. At the end of the day, imaging used solely, you're at the mercy of visibility. At the end of the day, it's a passive sensor. It relies on what light it gets around it. So perception is tied to the light that's available. With LiDAR, it's an active sensor where you're shooting a laser and getting the reflection. So you're creating your own light. So that is a major win in that case. Plus the depth data comes in basically instantaneously from the device, versus where you have to use computation to approximate the distance with 2D imaging. Mm-hmm. So you use various algorithms to do that, or AI to come up with the depth from 2D imaging. So it's kind of a secondary way of getting the data, while here you're getting it directly. So those are pluses. Really, the big hurdle is cost. I believe if SPAD arrays today were as cost effective as imagers, I think probably Elon Musk would have a different opinion. So I think if they had the resolution, if they had the cost structure, it may be more viable. But at the current state, it's still really a niche market at the high end. Level 4, maybe level 5.
Yeah. All right. Good. So I'm going to actually save my sensor fusion questions for a little later, because you mentioned it, but I want to move on. And one of the things I actually want to talk to you about, and you actually did bring that up, is the driver monitoring system. Driver monitoring system is becoming, I think, even more important when the car's going from level 2 to level 2 plus, and perhaps even level 3, right? And how the drivers are actually driving should be really monitored. Where do you think that the DMS technology is today? Is it up to speed to meet the regulators' requirements? I mean, obviously, Euro NCAP is far advanced in terms of asking car companies to install DMS by 2022 or one or two?
It's starting 2022. There are already some vehicles that have it,
right?
And expanding the NCAP score, that I think by 2025 it becomes effectively requirement almost to get the 5-star. So it's increasing in demand, which is a great path, and I'm glad and I'm encouraged by what Euro NCAP is doing. So first, Junko, with or without high-level autonomous features, I think DMS is very important. Even if you have no autonomous, high-level autonomous features, monitoring the driver drowsiness, whether you're driving a truck across the state, or with your children, and now with people always texting at times, I think it's an absolute must, and I'm very bullish on increasing in-cabin monitoring. We really need to expedite that front.
Yep.
Now back to your question, is it meeting the regulators? I'm surprised, because I don't know what the regulators' expectations are today. In my opinion, it's a glorified checkbox. Do you have driver monitoring? Check. There's not a lot of requirements and specifications. I do know that Euro NCAP is working with the community to make it a little bit more sophisticated. Some of the leaders in driver monitoring, like Seeing Machines, are actively involved in writing the standards and specs and helping guide that process. But today, it's, do you have driver monitoring or not? It's basically not much more than that. And you get the check, and okay, you get the check mark, and you proceed. It's not well regulated. We need a lot, just like we have it for electronic braking. We need more and more specifications to get up, set the bar on that front. There are challenges in driver monitoring that not every sensor can do and not every algorithm can do.
What are the challenges?
Well, there is, for example, just the near IR, near infrared response of a sensor impacts how you can see the driver's eyes. So if you have sunglasses on, the near infrared, by theory, should go through the sunglasses so you can see the person's eyes. But not all sunglasses are the same. You can have some that block the near IR, some allow it fully through, and some in between. There's a whole spectrum of that. So the near infrared, what's called quantum efficiency, how good is it is picking up even a small signal becomes really important. Another aspect is what's called global shutter efficiency. That means, and basically in a way, it's how good are you in blocking ambient light? Because the sun also has that light and it can confuse the sensor. So it thinks it's the light you're shining on the driver to see the eyes, but it's really coming from outside. So being able to block ambient light and just get the light that that it shined on the driver is very important. So those are two major items, obviously. And resolution, able to decipher small details, you know, as you're blinking is important. So all those features are important. And of course, the algorithms that use them are important. Whether it has redundancy, you know, does it look just on the eyes, or does it look on the shape of the face as well, or does it use both? So if one eye is blocked because I turn my head, can you still tell that I'm paying attention or not? So it becomes, there are quite a bit of sophisticated algorithms that do that. So all those are important, and but I'm quite bullish on it, and setting the requirements is important. I've seen the whole spectrum of solutions, and some are actually can be quite dangerous if you rely on it. If you rely on it, it will not detect that the person is not paying attention. So
no, that's
definitely standards are required. More testing and more standards are needed.
Let me ask you this, that, you know, when we're talking about vision to watch out for the road, for the ADAS functionalities, you know, external vision, you know, there are a lot of companies, including yourself, Mobileye, you know, a lot of companies sort of trying to take the leadership. And then I think the battle is still going on, but we're beginning to see that who are going to, you know, take a leadership role. But when it comes to DMS, driver monitoring system, what are the conditions that onsemi, for example, could become the Mobileye of the internal driver monitoring system? I mean, it's a leading vendor. Is that you need to combine? You need to actually partner with software algorithm companies, or what's the strategy here?
Yeah, On Semiconductor, I mean, prides itself in partnering and become really ecosystem friendly. We're not trying to take over the job of some of our partners. You know, we work with them quite well, and we have many algorithm partners in the driver monitoring space. We deliver semiconductor solutions to almost all the leading folks. I do know, you know, from, if you look at some of the industry reports, you'll see that Seeing Machines is nearly half that market. They're based in Australia. We work with them quite well. Others in Europe and Israel and the US. So, and Asia, of course. So we work with them in good collaboration and partnership and deliver our semiconductor solutions to them. Whether one of them will become the Mobileye versus others, it's tough to predict the future. But I do know with more processing capabilities, it kind of opens the door of putting those algorithms on existing processors. So, for example, a Mobileye chip could have the driver monitoring sit on that Mobileye chip as well as doing the ADAS functions.
I see.
It has the performance headroom that if you can put it on.
Sure.
So, and I think that's even has been announced that there is an open system that allows other algorithms, and they've had some partnerships with some of the driver monitoring folks to just let it reside on that same processor.
That makes
sense. So just
sense.
like our computer system, that it may have a drawing software and it has an email system, you could put that software on that same, Mobileye or NVIDIA or Intel and others.
Right. All right. But onsemi is not in the business of the processor, right? Or are you? I mean, that sort of platform processor for the ADAS verse and others?
We do make application-specific processors, for example, image signal processors.
Okay.
So if you take a raw sensor and you just want to create a human vision, a pretty picture, the selfie of the car for rear view or surround view, we do process that raw data and provide the human vision data. So more function specific and also application specific in our sister group as well. So it's really based on the need, fixed function need. We don't today make a general processor like the x86
that you don't
or
consider
ARM.
that your business. Yeah. Okay. Well, that's good. All right. So now this is we're getting into the little fun stuff that let's talk about active ADAS feature. We are talking about, I'm referring to the recent study done by, AAA, that they did the study both on the regular road as well as the test course. And they actually looked at the various vehicles, and they pretty much concluded that its performance of the active ADAS features are uneven. And, that was a little bit surprise to me. What was your take on this? I mean, I'm sure you saw the same report.
Yes. Yeah, Jungo, in all honesty, it wasn't a surprise to me. We work with a lot of these vendors, and we know that there are different algorithms and different architectures in these vehicles and different sensors. So their perception capability, their processing capability are different, and they have different strategies and theories on how to handle it. Some use traditional computer vision algorithms, some use a little bit more AI. So it varies from one to the other. It's not such a tight standard it's just like any car performance. Different cars perform differently. The ADAS systems perform differently. Mm-hmm. But the kind of the bumps in the road of ADAS that this report brings up is, hey, they don't work consistently all the time. You expected them to kind of work all the time with no failures. And even on that front, it wasn't a major surprise. Those systems, the tier ones or the algorithm folks or the car makers never claimed that they're a replacement to the driver. They're a set of tools for the driver to assist him in the driving. And as a user myself, it has assisted me, quote unquote, multiple times that would have been a potential accident. So I'm very thankful for them. And definitely, I think they do help. Whether it's hands off and I don't need to pay attention and it's going to take care of it 100% of the time, no, it's not there. Yeah. Again, there are perception challenges, cameras and radar and LiDARs that all come into play, and cost and system implementation that I think for the everyday light vehicle, you're getting the support, you're getting the assistance, but to hand over the keys to the machine, that's really, it's another level of more like the Waymo class of kind of vehicles that have a lot more redundancy, a lot more perception capabilities that I think would be.
No, that's true. But here's my soapbox. I understand that nobody said, no manufacturer is saying to the consumers that this is going to replace you, the driver. But at the same time, driver, once they're beginning to understand what the new car is capable of doing, they'll get used to it. I mean, they'll get used to it's a human nature. It is like how the machine, when we talk about the relationship between the car and driver, it is definitely when the driver, the more and more driver gets familiar with what the car is capable of doing, they begin to depend on this car to save his life. And even though it's not written, I mean, of course, there's always a disclaimer that you have to be responsible. Yeah, I get that. But in real life, people said, well, last time, they watch out for me, maybe I can just go down to get my, smartphone that's on the floor to pick it up while, I'm driving because the car is driving for me. I mean, there are certain instances, I know it's forbidden, but at the same time, that's a human nature. They begin to depend on the technology. What do we do about that?
Yeah, Jungo, you're absolutely right. People over trust. That could happen. You could have a bit of over trust in the system. And the call to action to the industry is they have to continue to improve it. They have to further make the standards harsh, more difficult to meet, to be honest. And NCAP has kind of done that, where the scoring has been low. You can get 5-star with very little ADAS, but they continue to raise the bar. Mm-hmm. So I think a gradual raising the bar is good as more adoption happens. But also, just kind of from a perspective, again, I can't name the vehicles or the sensors, but I can tell you that today's vehicles have technologies that were developed a few years back that now hit the market. Right. What you're going to see in the coming years is substantially improved solutions. Mm-hmm. I mean, from my perspective, from what I deliver to those solutions, for example, is, let's take cameras for a second. They're going to much higher resolutions, so they end up having wider field of view. So if you have wider field of view, you can see more vulnerable road users. You can control your lanes much better because you can see the lanes close and far, and you can see much more details further. So the whole experience will become more pleasant, even lane keep. In that report from AAA, if you look down into it, you'll see, for example, Subaru had disengaged because they couldn't see the lane markings that were faded at times. Well, that's due to the high dynamic range. How can you see the faded lane marks on the road? The new sensors have a lot more dynamic range, have a lot more pixels
that could change.
Wide field of view. So things are improving. Good news is coming. But I think the point you're bringing up, Junko, is that coming fast enough? Because people are getting used to it. Say, I'm going to start texting while the car is driving, and we've seen those instances on the highways at times. In
definitely.
The
news. As bad as it is, I mean, it's sort of you're conditioning the driver to trust me. The car is telling the driver, trust me, I can do this for you.
Yeah. I would say I would love to see if the evidence is clear and compelling that this is helping. If we go to another level of
that's
performance,
a good point.
That if we can have that compelling evidence, that other interested parties can help on the cost and of the system. What I mean by that is the car insurance companies, the health insurance companies. If you say today's solution is called, it's too prohibitive to the consumer to buy this car, but if we add, say, $1,000 of solution into this car, can it be compensated from whether it's health insurance or car insurance, because it's going to save lives and minimize accidents? That case and the math hasn't been clear so far to make that case.
And that can't happen without benchmarking, without rigorous benchmarking, because you can't just tell the insurance company that, well, I told you that this is going to save, it's easy to claim that, but it's so hard to claim something that did not happen. In other words, that this could have saved this. Had you had this feature, we would have saved your lives. But that's really hard to prove, right?
Yeah. It has to be a compelling marketing case for the car insurance and the health insurance companies to make that leap. It's not going to be a leap of faith.
Yeah.
There has to be a compelling marketing case on this.
Exactly. Yeah. All right. So I was saving this question towards the end. We talked a little bit about sensor fusion. Sensor fusion is always described as something that we can, this will give you the redundancy. This will compensate some weaknesses of one of the sensors. This is how it's explained. But it's never really clear to me that at what point fusion must happen. In other words, do you want each sensor to be prepped, at the really sensor node that prep the information and bring it to the central computing unit to do the fusion? Or do you want the central computing system would like to get all the raw data coming in and do the fusion there? What is the strategy here?
Mm-hmm. Yeah, I think what you're bringing up, Junko, is really about centralization of the processing. Should it be distributed, where at the edge of the vehicle near the sensor, you do some compute and then bring some metadata as opposed to the raw data, versus, no, send all the raw data, let me process it. There are different camps, and certainly the processor guys say, no, just send me all the raw data. So there's more hunger for more performance, and that I can do everything. There are pros and cons for both solutions. Certainly, if I send the raw data, it allows you to further innovate, and the keeping up with the pace of innovation on processors and smaller nodes, you can get, you're in the teraflops very quickly. So that there is a benefit there. Moore's law is helping the processor get more and more performance. So send me the raw data. But in certain cases, you do have some bottlenecks. For example, sending all that raw data is a lot of data coming in. So you need a lot of
all the cameras.
Interfaces. Yeah, cameras, even radar. Actually, radar is much more. If it's a raw radar, if it's just RF and you send it, it's several gigabits per second per radar. So if you have 4 of them, it's quite daunting in terms of data. So all the interfaces, all the cabling that comes into a central box become challenging, not just in the high speed, but also in terms of power and thermal. So it becomes challenging. There are some processing done at the edge, at the sensor, would translate into a more energy efficient solution. So on those aspects, definitely it makes sense to process those aspects at the sensor side.
Okay.
I'll give you an example. High dynamic range. In order for you to see a lane marking versus the road, you need to do high dynamic range. We take multiple images and combine them together and then send it to you. If I send you all the multiple images, let's say I have to send you 4 times as much data and you have to process them. So there are some advantages of doing things at the edge. So the partitioning has to be done appropriately and with clear system architecture in mind. And that's what we do often with the car makers and with the tier ones to figure out what should we do with the sensor, what should be done in the processor, and try to come up with a happy medium.
Right. Does that discussion actually, I mean, you said that there is a different schools of thoughts here. Are we coming to some sort of understanding or agreement in the industry, or it all depends?
Yeah, on certain things, I think there's agreement. Like the example I gave you is a clear one. This is the high dynamic range. It just makes sense. Certain other things, for example, should I detect objects and send you objects versus I'll just send you the raw data if I'm the sensor, or should I just send you the raw data and you process? There are different schools of thought. In the radar, there are radar processors, DSPs, right at the RF front end. That makes sense, especially for short-range radar.
Mhm.
So it all really depends, and in that one is more arguable. There's some that are prefer just send me all the data.
All the data.
It also depends how much headroom you have, how much performance you have in your processor. So an NVIDIA processor or Mobileye processor certainly have a lot in their new solutions. They have a lot of performance that could certainly handle that, but a small DSP or a small microcontroller certainly will not be. So it also depends how to best utilize the performance you have.
All right. All right. I'm going to conclude this interview with one question.
Okay.
When you look at the next 18 months, I'm looking at pretty short term here, the 18 months. What are the technology that you're most interested that automotive industry really needs? What is the technology that needs to be offered to the tier ones and OEMs? What are they looking for?
Wow. Okay. That's a good question. Certainly, just following up on our previous discussion, we talked about interfaces.
Yeah.
As we go to higher speeds and higher resolution sensors to give you more data to make a better decision to improve those AAA numbers, there's a bigger demand on the interfaces between those sensors to the central processor. So I think what the industry needs is an open standard that is provided by multiple semiconductor solutions. There are some initiatives. The one that has just been ratified is MIPI A-PHY that would help that. But such open standards that allow you to have multiple sources, not proprietary solutions
Plug
from
and
one
play,
over the other. I think the industry can certainly benefit of that, and it'll allow this good, friendly competition of bringing down the power, improving the performance and solutions. I think that would be really good, and it would serve all sensor modalities, whether it's camera, LiDAR, radar, everything.
It sort of opened the field, and it makes it easier for people to replace or use a new one without really changing
Multiple
entire
sources.
architecture, right? So what's the name of the standards? Standards there?
Well, it's part of MIPI, M-I-P-I, MIPI, and it's called A-PHY, just the capital A dash phi, P-H-Y.
Got it. So it's MIPI. It's one of the MIPI thing.
That's right. That's right. Okay. But it allows you to run over a single wire, longer distance, versus today's MIPI that you just have in your cell phone or short range, short distance.
Right. Yeah. Okay. Very good. I learned a lot. Thank you so much for your time. It was fun.
My pleasure. Thank you, Junjo. I enjoyed it as well.